Hi, good afternoon. I'm going to introduce myself. My name is José María Forteza. I am a member of the board at the Quantity Surveyors, Technical Architects and Building Engineers Association in Barcelona. And is it for me a great honor to be the facilitator for this afternoon session. Okay, let's start again, but in Spanish now. Well, it is a great honor for me to be the facilitator in this session. I am sure that it's going to be really interesting for all the attendees. And it is very exciting for me as a member of one of the institutions, the organizing institutions of the ABS, to see how many people are attending. This morning, the room was packed, actually. Now the participants are divided into three sessions, so maybe the room looks a little bit emptier, but it was really exciting to see so many people here. And also, I am thrilled by the level of the speakers that accompany us in this day and a half. And again, it is a great honor for me. Well, talking about speakers, allow me to introduce the speakers that are going to be in this session. In the first place, it is a great honor to have Christine Cavatallo with us. Christine, she is the director, project manager of the hospital center at the University of Montreal for Canon Design, which is the largest healthcare project in North America. When, or upon completion of this center, it will cover 2.4 million square feet, and it will provide assistance and healthcare for 345 million inpatients or patients or ambulatory patients. Christine Cavatallo, before that, was at design management at Microsoft's Global Data Center, and she's been responsible for many other projects worldwide. Among others, the World War II Memorial, the New Hoover Dam Bridge, and the Bypass Corridor. Cavatallo holds a Bachelor in Science in Architectural Engineering with an emphasis in construction management from the University of Kansas. So, please, Christine Cavatallo.
Buenas tardes. Good afternoon. All right, well, I am here to talk to you today about the SHUM project and our BIM initiatives that we took with this project. As you mentioned for us, it is the largest healthcare facility being built in North America right now. And when it is completed, it will be the largest healthcare institute in North America under one roof. So this is our project. So Canon Design plus NUF, our local partner architects, were lucky enough to be awarded the project at SHUM. As we mentioned, this is a magnificent scale and some interesting facts. The concept of unifying this hospital started in 1920. Yes, 1920. It's only taken a century for us to get here. So this hospital now is consolidating 3 current hospitals into a single building. As mentioned, 2.5 million square feet, very large, and it's hard to do the walkthrough during construction. We have 772 patient beds, and it is a $2 billion construction effort. Now, this is broken into 2 phases. Right now, we're finalizing phase 1, which is approximately 85% of this effort. So to undertake something like this took a huge effort. We had over 300 architects work on this project in the last 6 years. At our peak, which lasted about 2 years, we had 180 architects, which is pretty significant. We also utilized a 24-hour work cycle by utilizing multiple offices throughout the world, primarily Mumbai and Shanghai. So as I said, the shim was an interesting project for us. It had many challenges beginning day one. Our first challenge was that this is a 3P, or public-private partnership. So we were hired by the construction joint venture, and I believe some of you know the partners. OHL is one of them, as well as Lang O'Rourke out of the UK. Now, on top of that, some of the other challenges we had in front of us were the fact that this was also in Quebec, which mandated all documents be done in French, which many of us did not speak. So it made it a very new, interesting challenge as well. This is as built. This picture is just taken, and you can see the size and scale compared to the city of Montreal. So how do you execute a mega project? This was our challenge. So as most 3P projects, this had an extremely tight schedule, very aggressive. Also, this is one of the first major efforts the shim had ever undertaken, and they were combining 3 hospitals. So simply getting through the process was extremely taxing. We had over 3,000 hours of user group meetings with the client. So we really had to sit down and figure out how we were going to accomplish this work. So what we did, and we found so successful, is really designing our work process. So at the initiation of the project, we brought all of our key senior leadership in. That included BIM leadership, outside consultants, CDV on codebook, our design, planning, technical, and our project management leadership. We had a week-long, seemed like all hours of the day session where we actually designed the whole workflow for all the deliverables to manage for the full 10 years of the project. So we started day one looking at how many models are we going to have? What's the maximum size? How do we make those models usable by the team every day with no downtime? How do we achieve that 24-hour cycle? How do we use our servers? How do we link in models? How do we set up our work sets? So this was a detailed discussion where we literally designed and wrote a full execution plan. So first we had to break this down. How do we look at these buildings? Even though this is one building, there are logical pieces. So we started with that platform, and that helped us determine the number of models, the sizes of models. Next, one of the most tricky parts of this project, because as you all know, there are so many tools available to us now, and particularly in the US, where we've been using BIM for 10 to 15 years on projects, we're pretty facile, and there's a lot of add-ins, tools, et cetera. We had to define that up front, because again, this is a 10-year effort, 2 phases of work, and a large team engaged. So we had to be sure the tools we were selecting day one were going to live with us for 10 years and transition properly. We also had to set up how we deliver the project. What you're seeing here is about 1/3 the size of the overall sheet index list. And I don't mean individual sheets, I mean sheet types. Each of them was already established as far as what scale they would be delivered, the file names, etc. At the end of that 1-week session, what we developed is a base set of protocols or guidelines for the project. Even though Canon Design had done larger projects than shim in the past, we typically did the design architect role, where we would only take the project up to the DD stage, and we would hand it off. On Shum, we were now executing all the way from schematic design all the way through construction administration. So we really had to think about day one, how we used our models and how we were going to quote unquote draw, since most of this is all data driven. Everything had to have integrity from day one. We wanted every line or wall partition type inserted to have integrity from the first day to the very last day. We also said, how do we manage a project like this from a quality standpoint? How can we use our tools to help us do our quality control? So what we did is we embedded, using the data and the parameters available to us in BIM, the information we needed to see quickly. So in the upper, I guess that would be your upper left diagram, is a picture of how we looked at the acoustical and fire ratings or the abuse resistance within a wall partition type. All of that was color-coded. So we could easily take a drawing, run the acoustical values, color-coded, print it into Bluebeam with PDF, and then have our senior leadership look at that to verify that we had all the acoustical values properly set for the walls in the rooms in this healthcare facility. We also did things like that with doors, clearances for code, clearances for equipment, and et cetera. And it made our quality control process so much better and so much faster, particularly on the scale of this project. One of our most challenging items was how to deal with equipment. We have over 200,000 pieces of equipment in this project, and all of that had to be embedded within the models. So we worked very closely with Codebook, which was developed by Peter Mann out of the UK, and we used their database system for managing equipment. It interfaces with Revit. It was a godsend for us. Not only can you set up your rooms within Codebook to hold all your basic room data sheet information, air exchanges, acoustical ratings, hours of operation, etc., but you can dive in and insert your equipment and track what was originally to be in the project as required and what the output was today as designed. So this allowed us to also track changes as things occurred through this project. So this is taking it down to taking a piece of equipment, looking at that. The family that was built for Revit utilized all the parameters needed for tracking, from weight of equipment, so that could be shared with structural, for coordination of potential slab depressions, to MEP requirements. This held all of our data for us. What we did was then develop what we call building exemplars, departmental exemplars, and one-offs. So we took all this information that was housed in Codebook, and what we were able to do is when we had a single room type that needed to be repeated, is we built exemplars. And this is an example of an exemplar for an exam room. Now, the key to this is we did something that you don't typically do in BIM. We duplicated information. So we had an exemplar model sitting outside the system, and we had our production models over here. Now, the reason we did this is because we had such a tight schedule. We were literally doing schematic design and programming planning meetings with the client as we were producing construction documents. So we needed somewhere to test out, work through the room information with the client, have change occur on a regular basis, and then a way to continue construction documents that weren't in this total chaos every day due to the meetings with the client. This information in these exemplar models held everything that was critical to the room. What Codebook allowed us to do is once this room was finalized, we could take the configuration of the equipment and we could push that into any room associated with that exemplar. So for this exam room, we were able to take a finalized single exam room, push the equipment in the correct configuration into the 443 instances in the actual production model. That helped us to guarantee that we were getting the right final approved set of equipment in the room in its generally right location. Of course, we had to do a little adjustment on the actual size of the room in production and make sure that we were moving forward properly. So this is a little animation, if you will, of how this process worked. This is showing all the building exemplars. This is a room type that was shared throughout multiple buildings and multiple departments within the hospital. This is showing a departmental exemplar push. This would be something like a coronary care unit, which had a unique set of equipment, but it would get multiplied 30 times within a floor plate, and one-offs. This might be a specialty procedure room, for instance. Together, these loaded our building and our production models. We were able to load 225 rooms per night with 2 team members. And this was part of our 24-hour cycle. As our team in Montreal would finalize with the client, we could send that data with an email to say, go on the model, look at this is finalized, and please push these to their associated rooms to our Shanghai office, and we would come back in the morning in Montreal, and that was all loaded for us. Doors is another area where we used Codebook extensively. Codebook was not initially set up to work with doors. So we worked with Codebook and their development team to say, how can we add doors to this function? What we wanted to do is every room type also had an associated door type. An exam room has one type of door, and OR another type. We wanted to associate these with the rooms. So again, that QC ability that we could take and look at every door being consistent per exam room. We did have one problem with Revit, though. With Revit, when you run your door schedules, if you remove a door, it just disappears. We called up Autodesk, we said, we need your help. They could not find a solution for us on this one. So instead, we had to utilize Excel. And we came up with a system that would report out of Revit, track the changes from the last version sent out, highlight it in a manner that we could communicate changes to the field very easily. So they would clearly understand a door had been deleted and it wasn't missing. Now, one of the things that occurred through the project is, obviously, as much as we planned in those initial sessions, things continually evolved. So this team would meet on a regular basis and was always available on call if needed if we had a new issue arise. Two of the things that really challenged us, detailed referencing and equipment change management. So detailed referencing, this is a huge facility, and we wanted to draw all the details one time for phase 1, for phase 2, and for any building that it's used in. But as the project evolved, drawings would change. So we worked with an outside team because, again, we went to Autodesk. They could not find solutions for us. And we developed a tool that does automatic detail referencing for us. So you associate your detail once to the item once. If either of those move or change, it does an auto update, so we don't have to QC that. Equipment changes. We had over 100 versions of the equipment list. So it was quite extensive. And on multiple of those, they were changing 50% or more of the equipment on the project. So we really had to develop a tool to not just implement equipment like Codebook, but a process for how we did analysis and comparison. We also had a couple of historic features within the project. And again, we utilized BIM and how to move forward with those, down to the pieces that were existing and that we had in a warehouse, to the pieces that had to be newly constructed and how that would work. Of course, then we could do digital printing, much like Ignazi there, to take a look at these and make sure that these items were working properly. And then through construction and finalization. We also used computational design for the patterning on our exterior, not over the overall exterior facade, but also the new bridge or passerelle. And this was such a fun exercise for us. There were various approaches taken to this, and we would pin these up all over the office in front of the windows to see the quality of the light penetration, until we would get to the point where we could start developing models to see if we were achieving that penetration we wanted. This is the model that was selected. This is a rendering, and this is an image of the final product. And this is only the raceway for the mechanical units. And it's this gorgeous. I know, it's kind of funny. But it turned out just absolutely beautifully. So the goal was during the day, the light filters in, and at night, the light filters out, creating a beacon for the city. And it was highly effective. Now all I have left is a few images to show you how this worked for us. As I said, we wanted every item drawn day one to have integrity through the project. And we wanted to set up the entire process to make sure the integrity of the physical design played out properly throughout this effort. So this is an initial rendering done on the project, a final shot of the project. Another initial rendering, final graphic. This is just beautiful to walk in right now. Another one looking at how we were dealing with these stairs that had these highly complex forms, angles, etc., to the actual implementation. Corridors. One of the most interesting things about the scale of this project is our corridors became so phenomenally long, and we had to find ways to break up the spaces and make them identifiable. So again, color and light were used extensively to create those variations. This is our reality. So that's all I have for you today. Thank you very much.
Muchas gracias, Christine.
Thank you very much, Christine. It was really, really interesting. Now we will move to the following speakers. They are Fernando Morales and Nicola Paltrinieri. Fernando Morales is the director of BIM60 Consulting, which is located in Barcelona, and is specialized in the development of BIM projects and in the application of technological tools to improve the quality of projects, their productivity and management. He is an architect with more than 10 years of experience in the development of projects of hospital architecture and of large equipment. He's also BIM manager with experience in projects of high complexity of national and international character, and he's a specialist in energy and sustainable efficiency through the use of simulation tools. He has a degree in architecture by the School of Architecture of A Coruña, a master in degree in sustainable architecture and energy efficiency by Ramon Llull University, and also a postgraduate degree in BIM multi-platform management by the UPC. And together with Fernando, we have Nicola. Nicola Paltrinieri is a project director and BIM manager of the PINIARC architectural firm. He was born in Varese, Italy, and he's an architect. He has an architecture degree from the Faculty of Architecture at the University of Ferrara. He also has a post-degree in architecture and energy savings from the UPC at SAP, and advanced training in Revit and BIM management A3D. He has also worked in the BIM projects developed in his practice. Among them, we find the Linares project in Chile. He has worked in different projects and has done presentations in the European BIM Summit of 2015. And that's it. It seems quite a lot, huh? Please, you have the floor.
Hola, buenos días.
Good morning, or afternoon rather. We wanted to have this presentation together with Fernando Morales, and we wanted to show you this hospital project. In this project, we had the opportunity to manage the project at a design level, but also especially at a data level, content level of all the models. We worked in the Quillota Hospital in Chile, and this is a building and design project. We were awarded this project together with other companies, with SACIR, Vivats. It's not a very, very large project. It's actually about 280 beds, so it's actually way smaller than the project that Christine showed us. The budget is about 150 million euros, and basically the tender stated some specifications. We had the architecture guidelines. We also had the medical architectural program, of course. We had the draft for the architecture and structure. We had the consultant guidelines, and especially we had the Revit model. For us, this was quite a new thing because we started working with Revit many years ago, in 2009, and back then not many people used Revit. So it was always us, the ones who produced a model, and many times it was just basically some plans printed in PDF that stayed with the owner. This time we received the BIM model, and it was a new step for us. And well, you may wonder if you look at the basis on the left, what the next step would be. Basically, open the model and start working, right? Well, that's not the case at all, because in the best case scenario, what you see on screen will happen at the beginning of the project, but in the worst case scenario, this will happen when you only have 10 days to meet your deadline. So when you receive a model, you need to have an audit as deep and thorough as possible of the model that you receive. And afterwards, you need to develop a BEP where you will define the goals and strategies of the BIM model. You also need to rebuild the BIM model that you have received according to the strategy that you have decided to follow. And only after having done all these things, you can keep on developing the project, both at the geometric level and also at an information level. Therefore, after we have gone through these steps that we did together with BIM 6D, we were able to develop the project in all its stages. At the beginning, basically, we worked at a geometry level in the different scales of the project. Also, this project is very interesting because, as it happens with other hospital projects, such as the one that Christine showed us, these projects have different stages simultaneously. For example, maybe you start doing the schematic design, but at the same time, the construction company is already laying the foundations of the building and also the structure. So at the design level, it goes to room layout sheets, and the project, as I said, has been developed with BIM methodology, but it also describes geometry. But beyond geometry, there's much more with BIM. If we look at the other parts, we see that they are actually dominant in the project, the part that is not geometry. Many times architects are not used to manage all this huge amount of data and information. Many times architects nor clients nor builders make good use of this data, of this information. This data just stays within the model, and at the end we have a worker on site with a printed PDF that has the same graphic information as we had 50 years ago. Thank you. This is Fernando, Director of BDC Consulting. I'm a BIM manager. I'm also specialized in large equipment such as hospitals. Right now we are working with Pinearc in several projects. We cannot talk about some of the projects. We're not allowed to do so, but we are allowed to talk about this one. We also have larger projects than the one we are showing. But all the projects share some common features regarding actually how we manage the information, as Nicola was saying. And this is really important because that allows, or we are really aiming not to commit the same mistakes, that is forgetting all the information that the BIM model contains. Otherwise, we would stick to the 3D model. So I will talk about some of the tools for data management that we have applied for this project and also in other projects. But first, I will talk about the methodology. These kind of projects are very complex. And we also can observe that there is some kind of trend, maybe not in Spain, but in other projects. And it's the fact that there is a fast track contract. That doesn't mean only that things need to go at a very fast pace, but also that there are some other features that define this kind of development. For example, when a construction company is awarded a tender, the construction company needs to hire specialists, technical architects, and so on, so that they can carry on the project, so it's successful. We start from a BIM model that has been already developed, as Nicola was saying, but that doesn't mean the BIM model is valid and it's ready to keep on working on it, especially at the construction stage. We also need to mention that in this graphic we can see how geometry comes from the model, and we can modify it or maybe bring new information to geometry, but you cannot really do much more. However, data keeps increasing, and also the requirements of the project will demand more data than the ones that we originally had. In large projects, our experience is that we need to develop two kinds of models: general models and detailed models, space by space, for specific areas of the project. On the left, we have the general models, where we can see different disciplines, and each team has their own model that they own. For example, interior designers, architects, equipment companies, and so on. And these models need to be coordinated. Therefore, here we have the BIM manager, we have the coordinators, and as you see, all these models need to be coordinated. There cannot be clashes among them, and they need to be to have good quality. Then we also have the detailed model. This is a requirement from the client because they want to have detailed information about each space in the hospital. I even defined each of the elements in each space. That's what we were asked to do. So at the end, we have some graphic sheets. And what these are is just some drawings, some detailed drawings where we have different elements and a codification for each one of the elements in that space. We also have the technical sheet that are basically documents of thousands of pages even. I cannot even think how many pages they must have for the project that Christine explained, because they contain so much information. So these documents are spreadsheets, and they detail all the features of each of the components. So with all this information, What we need to do is developing a methodology that will help to use this information so that we can collect it and we can adapt it to the general models that are being developed. Therefore, that means we need to have coordination in the development as we work in the project. We do this through programming, and what we achieve is a model that cannot evolve really much more geometrically, but is loaded with much more information that is needed for the project. In order to explain how we do this, what process we follow to generate all this data, we need to keep into account different things. Not all the specialists that work in these projects are familiar with BIM tools. Maybe they do not even know about data management tools. That's why we have developed a system based on Excel files, because pretty much everyone knows to work with Excel files, but they are organized in a specific way. Some areas are blocked, some areas are really well structured so that everyone knows what they need to fill in. All these Excels are linked. Each team has their own Excel files, but at the end, what we achieve by doing this is that we can develop the models, and we also have a database. So basically, then we link this database back to the models when we need it. The information comes from different sources. When we start a project, for example, it comes from the model that has been already developed before, but also comes from the specification, the tender specification documents that can have a PDF format, doc format, and so on. All this information needs to be classified, needs to be codified and structured in the same way. And this is actually very, very thorough work. We need to conform this structured database. And once we have done this, we have linked these Excel files, we will have the capacity to create these technical sheets in order to link them to the models. Once we have these models with all this information in them, we are able to use more complex tools that are based in clouding computing systems, and also allow us to have different visualization models for geometry and data. The tools that we use to manage all the BIM models in the cloud are divided in two types. On the right, we have the geometry visualization tools. For example, this is from Todes. And they can be set up in different ways so that we can create filters, we can sort out depending on colors, to understand better depending on the parameters of the project and also the complexity of the project. On the left, we have another tool. This is the one that we are developing currently, and this is based in reading the data and how we can visualize them. In BIM, data is hidden, so we try to make it more visible. We try that everyone can work with the data. We don't want all the properties one by one, but what we want to do is have all the properties together inside a project, and all together we can do some operations and actions so that we can assess in real time whether we are complying with the requirements of the project or not. For example, regarding surface, the area, measures or costs. And this has a high potential for construction companies, because as they develop projects, you would be able to see if measurements and costs are okay to what compared to the planning that had been done. For example, in a hospital, we can see if the initial planning is being respected throughout the design stage. But let me show you in real time how the tool works. Okay, here you can see that we can create different sheets. In each one, we can have a different setup. We can define in real time the database of the BIM models. If they come from different sources, there's a cloud server where all the databases can be updated. First, we need to set up these graphics, but once this is done, we can see all the progress that has been done and achieved. Here, for example, we are seeing if we fulfill the planned development. We sort out by areas, and in blue or orange here we see if we are meeting the requirements and if we are fulfilling the ratios in design compared to the initial planning. We can also zoom in. This is the 4th floor. We are selecting different areas, and we can see also the surfaces, for example, how many beds we have per square meters. We can also sort out by different parameters, any other parameter we need. It would have been really useful to have thought about this earlier. That means, we plan everything together with the BEP and all the requirements for the project. But in any case, we did that afterwards, and it's still being really useful anyways. Here we see measurements. We can establish a value, for example, 50 square meters. And here we can see what selections we are choosing to see if they are within or outside the ranks. And here we have another example. For example, facade study. At the end, what we need to have is a well-codified model so that we can control the information, and we can sort out and apply filters depending on locations, and we can also check the properties of the different elements. What is interesting here is that we can check data from external sources, and we can also make calculations to see if a number is larger or smaller than other numbers, and do all the calculations we need so that we can figure it out if the project is meeting the requirements or not. As a conclusion, we would like to make clear that the data included within the BIM model is really interesting, and it's interesting to visualize them. Because if the participants in the project can visualize them, but they cannot really manage the model, well, they can help with decision making. For example, if I know I can participate in the costs of the building, but at the same time maintaining the quality of the architectural part, then this tool is great, because anyone can go check the database and they can adjust the budget or the functional plan depending on their needs without really needing to go into the geometry model. I also would like to add, I'm not sure if you will agree with me or not, but as we evolve with BIM, for us it becomes more important the I in BIM, that is the information, that is even more important than geometry, I would say, because at the end, all these projects are basically working through the information that these projects generate, and that's what we take and what we use. That's it. Thank you.
Espera, no bajéis, no. Bueno.
Well, thank you very much, Fernando and Nicola. Thank you. We have some time to have some questions. Anyone maybe wants to say something or ask something to our speakers. Okay, there's no one, but luckily I had prepared some questions. So I will actually say a couple things so that we can use the time that is left. This morning we were really stressed with timing, but now we have more time so we can relax a little bit and enjoy the company of our speakers. And I wanted to actually ask a couple things. Anyone can answer, either Christine or Fernando, Nicola, whoever thinks can answer better. Why has BIM developed in such an advanced way for this kind of projects, hospital projects?
One of the reasons it's become so utilized within healthcare is because the amount of information, the capital I, as Fernando said, that we need to track within a hospital project, be it the equipment, be it the acoustics, be it any other parameters, lead shielding, etc., that it just lends itself to this so readily. Also, I think a lot more of the sophisticated contractors are doing healthcare projects because they are a little more complex, and they are demanding, at least in the North America, that we're all utilizing this tool because it helps them with the construction effort as well.
Yo igual me gustaría añadir una cosa.
I also would like to add something, and I think that BIM at hospitals maybe started because of the effort that the hospital needs to make at the management level. I think that by knowing that there is so much information and parameters that need to be managed at the hospital, then it creates that management is really expensive and really complex. So the more organized it is, the more you save. And that means that if we can do that with management, maybe we can do that too in the building stage. And that's how it was, actually. This is the only way we have to manage a building that starts with maybe 40,000 square meters and that ends up being 3 or 4 times as much. There's no doubt that the complexity of a building such as a hospital is the top level regarding costs and also finishing. It makes it very complicated. Also another question, for future projects, what are the lessons learned? What would you say in the BEP in the phase of procurement of a building? Maybe not such a large building, but a building with the characteristics of the healthcare building, such as the ones we're talking about. In my opinion, we cannot only think of the things in the BEP, but we also need to understand all the stakeholders that participate, and especially the ones making decisions, and we need to make them aware of how important this document is. We need to let them know what characteristics need to be developed in this project and what things will be more important. And I think that everyone participating and making decisions should know about this. Of course, if there are improvements afterwards, that's great, but we need to start here from this starting point.
The other things kind of paired with that is training, whether it's for your client or for your own team. As the lessons learned for us, we went into this project knowing that it was a 3P and it had a 30-year life cycle because part of the overall contract is the maintenance. But what we found so interesting for us is that day one, we built these information models to contain enough data to take this project through the 30 years. However, our client was not quite up to speed with that. And I think the more we can do as an industry to not only train our own internal teams in how to utilize these tools, but to train our clients how to use these tools and the benefits it brings them, they're going to encourage it more, they're going to engage with us more, and they're going to look for us to be part of their long-term solutions. And I think that's somewhere we really have to go and something we learned on SHUM.
Estoy totalmente de acuerdo. De hecho,
I totally agree. Actually, many times architects forget that we are not the only participants in the process. We know that there are engineers, we know that, but sometimes we forget that the client has some needs, and that then we take these needs and we decide what needs to be done. But the client is a key part in developing a project. And of course, architects know this, but I think that many times when there's a new tool, technicians shut down and they don't want to use it. And I think that's wrong. I think we need to be open to this. And the client also needs to be part of the process. And also in the processes that lead us to draft a BEP. Because this is a live tool. Sometimes some weeks are crazy, there's a lot of work, but then you need to fix the system, but then the system is tested, is solved, and this is a never-ending process. To finish, what recommendations would you give to a developer or to an owner who needs to order a building, a hospital building, when they need to start the project? What recommendations would you give them, or should they keep in mind?
A BIM standpoint, again, it all comes back to how the information is going to be utilized long term and how you set it up day one. I know with all of our new healthcare clients, we've really instituted a very intense onboarding with our client at the very beginning of the project to do just that and to get them engaged in that. And same thing with the contractors. You know, the more we can get them involved, the more we can reduce cost for our client, the more we can accelerate construction for them. All these tools really are quite impressive when you put them together and you all utilize them together.
One of the recommendations I would give to the builder and also to the person in charge of the development of the building is that they make good use of the huge amount of data that they receive, not only for the building process, but also for the maintenance process. Many speakers have already talked about the facility management, and I think that's something key. The BIM at the project level is a base. If that is planned in the BEP, that can facilitate the transition to the facility management using BIM tools. In my opinion, what I would say is that if you are going to use the BIM technology in a project this way, we need to tell the client that he needs to have assessment and also guidance. This is the way the client will be able to have control on what is being done with BIM. And for this reason, I think public institutions should become involved in this idea of the BIM manager. Any questions from the public? No? Okay. Then I will ask for a big round of applause for our speakers. Thank you very much.